So it is time to get into something new called inequalities. Now, the idea of inequalities are several pieces and parts to it that we've already taught, gone over, and you've known for quite some time. However, putting it all together is something brand new. Being able to graph it is something brand new. So I really need you to be paying attention and taking good notes and engaging in the active listening process because this is important for you to understand and be able to build on from this point forward, not just for sixth grade, but in middle school and high school. So this lesson today is just about taking the notes. Tomorrow we'll just take the time, we'll do some quick review, but then we'll get into the assignment and just have work time for that. So make sure you're focused, taking notes, and let's begin. So let's get into our lesson objective before we get into understanding exactly what this means. So we want to be able to not just understand inequalities, but identify solutions to them. We also want to be able to graph them. So understanding several different things is why this is just going to be a lesson and taking notes. So let's start with the big fancy idea of the word inequality. Well, let's listen to what it sounds like. It sounds like any, A-N-Y, quality, any number. And that's exactly what it means. An inequality is telling us that the variable can be equal to any number at all. Let's look at an example of an inequality. We have 1 plus x is greater than or equal to 6. Well, that seems really complicated. What in the world am I supposed to do? Well, you're just going to ignore the arrow. You're going to ignore the greater than or equal to sign and just imagine that it was an equal sign. And you're going to start by doing the opposite function on the opposite side, which is why we've spent so much time doing algebra, because we have to be able to solve for the variable. We're just going to ignore that there's a sign there other than an equal sign and imagine, it's just an equal sign. We'll focus in on it. So my first step is to get my variable alone. What is my variable? My variable is x. And what am I doing to it? Well, I'm adding 1 to it. So what is the opposite of adding 1? Subtracting 1, which allows me to cancel it out. That gives me my x and my sign of greater than or equal to. And then I'm just going to do it on the opposite side, just like we do any other algebra. So 6 minus 1 gives me 5. So what we're saying is that x is greater than or equal to 5. So remember that when I have a greater than or equal to sign that has a line underneath it, that means it could be equal to. So we're saying that x could be equal to 5. But notice I keep saying could be, because it could be 5, right? But it could also be 6 or 7 or 8, 9, 10, 11, or any other number that would continue on. So that's when we have to learn how to graph them, because graphing them would indicate every single number. If I made you write all the answers that x could be equal to in this inequality, then you would be able to do that for the rest of your life, since numbers don't stop. They just have to start at 5 and continue on. So when it comes to inequalities, understanding that there's a wide variety of numbers that it could be equal to, because it's any quality, because it's an inequality. Make sense? Play on words. So we want to know, could it be equal to a specific number? Could it not be equal to a specific number? And what other numbers could it be equal to? So let's look at some examples. We're going to use the variable of n. We're going to have a greater than or less than sign, and we're going to have our pound sign, our number sign, which your generation calls a hashtag. So my variable, I want to figure out what my variable could be equal to. Now, reviewing what our greater than, less than signs are telling us. Think back to the Robin Hood image that I used before, talking about an arrowhead. The point always goes to the smallest number. The opening is always going to be the big one, right? So on this first example, we know that my variable is less than whatever number is given because the arrow is pointing to it. So let's just say this is the number that would be given. The arrow is pointing to it. So I circle where this number would be. We've been used to putting dots. But we have to change that now because it's inequality, and we have to know that an open circle means this is where it's going to start, but it cannot include this number. So it has to be any number that is smaller than the given amount. And I indicate that it's any number smaller than the given amount by shading in the rest of the number line from that point to the left. In the same way, if my arrow is pointing at the number itself and my variable is greater than the number, so once again, the number that's given, the arrow is pointing to it, and the arrow always points to the smallest number. So my variable is the larger, it's the bigger number of all of them. And we know the bigger numbers always go to the right. So wherever the beginning number is, I'm going to circle it on my number line because that's the amount that's told to us. But I know it can't be equal to that, so I just leave it as an open circle. Since n is greater than, my variable is greater than, all numbers that are greater than go to the right. So I fill in my arrow to the right. But we also have those that have the equal to, and that's where it does change a little bit. So we still have the same setup, right? We still have a variable that is less than or equal to a given number. When I start looking at it, I start plotting the exact same way. I figure out where the number is that's given on the number line. So we're going to say that it's here. Now I have to ask, can it be equal to that number? Well, since that is underlined, my greater than less than sign is underlined, it could be equal to. So the way that we indicate that it's equal to or could be equal to is we fill in the circle. Right? So that underlined simply means that it could be equal to. So now we're going to fill in the circle where the first number is. Then I have to do the arrow. The arrow is pointing to the smaller number. Now, please don't think that since it's pointing to the left, I'm just going to shade into the left because that's not always the case because the smaller number could be on the opposite side. So I'm always going to look at where the arrow is pointing. The arrow is pointing to the smaller number. I know it has to be equal or less than, so I'm going to shade to the left. I'm going to do the same thing with the last one. I can see that my number, in this case, my variable, is greater than or equal to the number given. And if I have that type of inequality, then I look at where's the arrow pointing. It's pointing to the smallest number. This number is greater than the number that's given. So I'm going to circle where the number might be on the number line, and I'm going to say, can it be equal to it? Well, it is underlined. So yes, it can be equal to it. So I'm going to shade in the circle. Then I'm going to ask, well, is my variable larger or smaller? Well, my variable is anything that's equal or larger than, so I shade it in. Once again, why are we shading this in? Because if I don't, then I have to write down every possible answer that my variable of n could be equal to, and numbers never stop. So you'd never be able to stop listing the numbers of your answers to answer a question. So when we look at the idea of inequalities, we can describe them in different words, right? So in this example, it says a person must be at least 18 years old to vote. So my number and my label is 18 years. Write an inequality to represent the possible ages of the voter. So I know what I'm being asked to do is write an inequality, but then I have to look at the key words. The key words in this one, once again, are going to be at least. And at least tells us which way that arrow is going to point. Can a person be younger than 18? No, right? It's impossible. The youngest that we can go is 18. So can a person be 18? Well, a person must be at least 18. So that terminology says, yes, they could be 18. So I know I have an answer that it's equal to, but can a person then be older than 18? Yeah, and that's what it's saying. 18 is the lowest that we can go. So when we start looking at what we're being told, right? If I am asked to describe it in my assignments, then I would say the age of the voter is greater than or equal to 18 years. So if we're going to say, well, we're going to use the variable of A to represent the age, and I need to write an inequality because that's what we underlined when we cubed our word problem. And then we're going to say that A, whatever the individual's age is, has to be greater than or equal to, because that's what that underline means, 18. So could they be 18? Yes. Could they be 19? Yes. Could they be 100? Yes. Could they be 15? No. So it's any age that is greater than or equal to 18 is what we're showing. All right. So now it says in some states you must be at least 16 years old to have a driver's license. So I have my number and label of 16. I'm being asked to write an inequality to represent this scenario. And once again, I go back to the idea of using the math terms at least. So I know that we're doing greater than or less than. So I need to go through my questions. Can a person be younger than 16? Well, that terminology of at least 16, then no, that's the lowest age that I can go. Can the person be 16? Yes, because at least means 16 is included in my possible answers. Can the person be older than 16? Sure can. So that tells me how to set up my inequality. If the valid driver's license means that you are 16 or older, and I want to use the idea of A, my variable, to equal the age once again, then I know that A is going to be greater than or equal to 16. Once again, the arrow is pointing to the smallest number, 16. We could be 16, or we could be any age older than 16. All right, so let's look at what this is saying. All right, so once again, we're going to cube our word problems. A certain hotel only permits dogs that weigh less than 50 pounds to stay with hotel guests. Write an inequality that can be used to represent the weight, W, of dogs that are permitted to stay at the hotel. So when I'm looking at my numbers and labels, I have 50 pounds. I also have that I'm representing the weight with the variable of W. I'm to write an inequality showing the weight of dogs that are permitted at the hotel. What are my keywords? Well, my keywords in this situation are less than, so we know which way the arrow will need to point. But I go through my questions to make sure that I set it up correctly. Can a dog be less than 50 pounds? Yes, because that's what it says. Can a dog be 50 pounds? No, because it says it has to be less than 50 pounds. So if it's a 50-pound dog has to stay in the vehicle, can't come in. Can a dog be more than 50 pounds? No, that's completely contrary to what it is saying. So if I know that it's 50 and I have my weight for my variable of W, then which way does the arrow have to point? So the arrow, once again, always has to point to the smallest number. And in this case, we know that our variable is less than the number 50 that's given. So my arrow is going to point to the W. And this says any weight that is less than 50. So when we're given a straightforward inequality and we're asked to graph it, we're going to go through those same three questions. First thing I want to do is I want to read what this is saying. So if you don't understand how to read it, then I go to the inequality and then it says x is greater than 3. I know that it's saying that x is greater than 3 because I know in my mind the arrow always points to the smallest number. And therefore, since the x is not being pointed to, it has to be greater than. I could flip it and have the 3 first, and then the arrow pointing to the 3 and the x on the right. And then it would be saying that 3 is less than x, which still would include the same group of numbers. So it doesn't matter really which way it's going to, as long as I can tell where the arrow is pointing, because the arrow will always, always, always point to the smallest number. Now I'm going to go through those same three questions that I did in the word problems. So I'm looking at the idea of 3, and I want to know, can my variable of x be 3? No, it can't. And I know it can't because the greater than less than sign is not underlined. So therefore, I'm going to go to the number line where the number 3 is, and I'm simply going to put a circle on the number line because I know that's where my variable answers are going to start. Now, can it be less than 3? Well, no, because it's saying that x is greater, right? And that point to the arrow is pointing to the smallest number. So, no, the numbers have to be smaller than 3. So, if I'm looking at the idea of more than 3, which is where the big number is, which is where the variable is, then I have to say yes. And if I say yes, then I know I'm going to fill in all the possible answers going to the right. Now, this is a number line. Notice there are arrows beginning and ending on the number line because numbers go on forever and ever and ever. So when I shade in my arrow going to the right, that would include all numbers greater than 3. All right? So if x cannot be 3, it can be anything larger or bigger than 3. That's what the inequality is telling me. Now, I would pause that after taking your notes, go back and review it, and just listen to me explain it because I'm going to be explaining these the exact same way over and over and over again. And this is brand new for you. And with brand new stuff, sixth graders often just say, oh, this is way too confusing. And it's not. It's very basic math steps and understanding relationship of numbers. Everyone in our class can understand this. Just need to put forth the effort. So let's look at this setup. This is saying to graph the inequality, the way I read this is x is less than -1. How do I know it says that? Well, if the variable is being pointed to, then that means it's the smallest one. So x is less than -1. I have to go back through my same questions, right? Can it be equal to -1? No, because it's not underlined. So my first step is to simply put a circle at the -1. Now I ask, can it be less than -1? Yeah, because that's what it's saying. And if the answer is yes, I don't need to ask, can it be greater than? Because I know that answer is no, right? So it can be less than -1. So which way do I shade it? Well, once again, smaller values always go to the left. On the negative numbers, the digit itself does increase, but that means it's further from 0 and therefore its value is less. So I'm going to draw my arrow and shade it in going to the left. Now, if you prefer to use a highlighter or a marker or something, as long as it doesn't bleed through your assignment paper, then I'm fine with that. Or just make sure you shade it in real well with your pencil. Don't just draw on top of the number line with your pencil and expect me to see it, because your pencil head is usually the same width as the number line itself. So when I look at what this is telling me, I know that x cannot be equal to -1 because it's just circled, but it can be anything smaller than -1. And those numbers, once again, would go on forever. All right, so let's go through these two. Once again, this is new and I know it's new and it looks really confusing, but it's not. Just go through the steps and process. What I would suggest, once again, take the notes and write them down. Make sure you're following along. Then, once your notes are taken for this slide, rewind the video and rewatch it so that you can listen to how I'm explaining it. I'm going to go slow, and for some of you, I'm going to go too slow. Some of you, it's going to be too fast, but you're in control of the speed of the video. But I need you to understand this concept. So I first start by reading what the inequality says. It says that x is less than or equal to 2. Once again, how do I know it says that? Because when I look at my variable, it's being pointed to, and the arrow will always point to the smallest number. I know it could be equal to because it's underlined. So I have this particular setup where it's going to be smaller or equal to the number given. So can it be 2? Yes, it can be. And if it can be 2, I know, once again, it's going to be underlined. So therefore, I'm going to plot it. Now, if it's not underlined, if it's just greater than or less than, then I just put a circle where that number is that's given in the inequality. However, since it is underlined and it could be equal to, we're going to plot it. Not only am I going to put a circle, but I'm going to fill in the circle. So I find where the 2 is on the number line and I plot it. I fill it in. My second question, can it be less than 2? Yes, because that's what it's saying. The variable of x is being pointed to. That is the smallest number. So therefore, it could be anything less than 2 as well. So I'm going to shade always to the left. Do I need to ask my third question about it being larger or bigger? No, because I already found out what all of my possible answers are. Once again, they could go on forever and ever and ever, and that's why we fill in with an arrow the entire number line. Now, if you want to use highlighters or colored pencils or markers, as long as it doesn't bleed through your paper, I'm fine with it. But please don't just take a pencil and mark over the number line because your pencil head is usually about as wide as the number line itself. And I can't see it. So you need to make sure that I can tell which side of the number line is shaded in. Let's look at the next one. Well, first it says what we're seeing here being plotted says that x, my variable, can be equal to 2. It's a filled in circle, or it could be anything smaller because it's shaded into the left. Now we look at the next one, and that is saying that x is greater than or equal to -7. I know that's what it says because the arrow is pointing to the -7. That has to be the smallest number. I know it could be equal to because it is underlined. So I'm going to follow my setup and I'm going to go through my questions. I'm dealing with -7. Can it be -7? Well, that answer once again is yes, because it is underlined. So if it's underlined and it can be -7, I'm going to plot it. I'm going to put my circle there and I'm going to fill it in. And then I'm going to ask, can it possibly be smaller? Well, it can't be smaller, right? It can't be less than -7 because the arrow is pointing at the -7, which indicates that's the smallest number that it can be. So if that's a no, then I go to my third question. Can it be greater? Can it be more? Can it be bigger than -7? Yes, because the x is on the opposite side of the arrowhead, so my variable is indeed bigger. So if it's bigger, then I know I'm going to shade my number line to the right. That's telling me that my variable of x can be -7 or anything greater, anything bigger than -7. And once again, in positive and negatives, when it comes to integers, for the negative numbers, the digits themselves get smaller, but their value is greater because they're getting closer to 0. Now, they are going to, of course, try to trick you and confuse you by giving you decimals and giving you positive and negative decimals, as well as fractions, mixed numbers, positive and negative ones. Don't let them confuse you. You know how to do this. Let's start by asking what the inequality says. X is less than -5 and 75 hundredths, or 5.75. How do I know it says it's less than? Because once again, the arrow is pointing to the smallest number. If that's the case, I begin asking my questions. Can it be equal to -5.75 or -5 and 75 hundredths? No. And if it's no, then I have to circle it. But where is it? Well, if I zoom in on my number line, I can see between each of the numbers there are 4 spaces. So I know that each one is worth how much? Well, one whole divided into 4 pieces, that's equal to 25%, right? 0.25. A dollar gets cut up equally into 4 quarters, and each one is worth 25 cents. My point being is that it goes in the order of -25, a quarter, -50, 2 quarters, negative 75 3/4, and then your 4/4 would be your negative 1. So I'm going to negative 5.75 3/4 of the way. So I start from my negative 5 and I have to move over 3, close to the negative 6. All right, then I go to my next question. Can it be less than? Well, yes, that's what the inequalities tell me. X is less than the negative 5 and 75/100ths. So I know I'm going to shade in my number line to the left. I don't need to ask my third question about being greater because it's not pertinent to this inequality. So what about the next one then? On the next one, it says x is greater than 1 2/5. So when I start looking at greater than, right, the arrow is pointing to the smallest number, I know that I can ask my questions. Can it be equal to 1 2/5? That's a no because it's not underlined, right? And then when I start looking at the idea of circling it, then I have 1 2/5. I have to find it on my number line. That's already written for me, so all I have to do is circle it since it can't be equal to it. And then I ask, can it be less than? Well, no, because the arrow is pointing to the 1 2/5. So that has to be my smallest number. Since that's a no, then I'm going to ask my last question. Can it be more than? Can it be bigger? Can it be greater than 1 2/5? That's a yes. So I know I'm going to shade to the right. Each and every time these will be solved the exact same way. Graph the inequality that x is greater than or equal to 2/5. So I'm going to focus in on my x is greater than or equal to. I'm going to ask my questions. If it can be 2/5, yes, it can, since it's underlined. And since it's underlined, that means I'm going to plot it. How do I plot it? I circle it and then fill it in. So I'm looking for 2/5 on the right-hand side because it's positive 2/5. So I fill it in, I plot it on the number line. Can it be less than 2/5? The arrow is pointing to the smallest number, which is 2/5. So no, it can't be less than 2/5. Can it be greater? Yes. And since that's a yes, then I know that I'm going to shade to the right. That is anything that is larger. All right, so I want you to try this one. Let's see how you do. Come back after you have it answered and let's see if you get to the right answer. All right, so hopefully you've done as I've asked. And then you started asking yourself, well, what does this inequality say? The arrow is pointing to the x, so that means x is less than or equal to, because it's underlined, negative 75/100. Okay, so if that's the case, then I have to ask my questions. Can it be equal to negative 75/100? Yes, because it's underlined. And since it's underlined, that means I have to fill in with a circle. I have to plot it. So I plot negative 75/100. I find it on my number line. I put my circle and I fill it in. Since it can be equal to, now I ask, can it be less than? That's a yes as well because the arrow is pointing to it. Since it is less than, then that means I'm going to shade which direction? Hopefully you shaded to the left because that's where everything that is less than is located. All right, so how are we doing on inequalities? Remember, today is all about notes, and I know you don't like really long math lessons, but if you need to, go back and rewatch some of these and listen to the explanation without having to write anything down so that you're understanding it so that when we get into word problems, you know exactly what we're doing. All right, so now they kind of switch it. They're going to give you an inequality, not just an inequality, an algebraic inequality. And that means there's algebra to do. And please don't freak out on me because all we're going to do is treat it the exact same way we have been for the past 3 weeks. They're going to give me some possible numbers to use that I can plug in for my variable. Right? So when I see my list of 5, 6, 7, 8, and 9, I want to plug that in. I want to substitute it in for the variable of x and just see if it's going to make a true statement or not. So if I have 2 plus x is greater than 9, and I plug the 5 in to that inequality, what do I get as my answer? Well, I would have 2 plus 5 is greater than 9. And then I solve for that. 2 plus 5 is 7. Is 7 greater than 9? Well, no. So 5 can't be a possible answer. So I look at 6. I'm going to substitute in to my inequality. 2 plus 6 is greater than 9. And then I add 7 plus 6 is 8, so 8 is greater than 9. Is that a true statement? No, that's not a true statement either. All right, now we substitute in with 7. I have 2 plus 7 is greater than 9. Is that going to be a true statement? Well, 2 plus 7 is 9. Is 9 greater than 9? That's a no as well. Now, if it was underlined, I could say yes, because it would be greater than or equal to. But that's not what it says. So we should be able to say, well, then my next numbers are larger, so I have 2 yeses, but I have to prove it mathematically. So we plug them in into our math inequality expression, or equation. We have 2 plus 8 is greater than 9. 2 plus 8 is 10. Is 10 greater than 9? Yes. Then I do the same thing with 9. 2 plus 9 is greater than 9. And 2 plus 9 is 11. Is 11 greater than 9? That's a yes as well. So the whole numbers out of my possibilities of 5, 6, 7, 8, and 9 that are indeed solutions that give me a yes answer to my inequality of 2 plus x is greater than 9 are 8 and 9. Okay, so it's just thinking about what it's saying and going through the steps to prove it. Yes, you have to do this. So this is going to be seen on your assignment in our next class. You're going to be given the inequalities. You're going to have a colon at the end, and you're going to have a list of 2, 3, 4 different numbers. That colon is separating the numbers you have to use to plug in for your variable into the inequality. So the inequality says that a plus 4 is less than or equal to 11, and you have to try 6, 7, and 8. So that means on those, you have 3 different math problems to do, and you have to find the correct answers. So we have 6. We're going to plug it in to our inequality. I have a plus 4 is less than or equal to 11. When I plug that in with the 6, then I have 6 plus 4 is less than or equal to 11. Is that a true statement? Well, I have to do the math. 6 plus 4 is 10. Is 10 less than or equal to 11? Yes, that's a true statement. All right, what about 7? So I'm going to plug it in to the inequality. 7 plus 4 is less than or equal to 11. Then I do the math. 7 plus 4, that's 11. Is 11 less than or equal to 11? That's a yes as well, because once again, it is underlined, so it can be equal to the number. Then I do it with 8. Now it's larger, so hopefully we just know that it's a no, but we do have to do the math to prove it. So I'm going to plug it in, and I'm going to have the inequality of 8 plus 4 is less than or equal to 11. I do the math. 8 plus 4 is 12. Is 12 less than or equal to 11? That answer is no. So my two solutions in this particular inequality is 6 and 7. We got it? We understand it? Hopefully, because I want you to try this one. Once again, I'm going to read it to you so you understand how it's all set up. One thing I don't like about this book adoption is the colon. It just kind of squishes all my possible answers together. So what this is saying is that you have the inequality of C plus 28 that is greater than 72. The colon tells you your numbers to substitute in are, and then they give you 3, 44, 45, and 46. So I want you to solve all 3 of those problems and figure out which one or ones are the answers. All right, so hopefully you have done it, you've unpaused it, and you have 3 problems that you have worked out, substituting each and every time with each of the 3 possible answers. So they give us 44. So you should have had that 44 plus 28 is greater than 72. The greater than 72, just like on an equal sign, when I'm solving for my variables, I'm just going to bring those down. Then I do the math on the left-hand side. 8 plus 4, well, that's going to be 2, carry my 1, 70, so 72. 72 is greater than 72. Is that true? Nope, that's not true. So 44 is not a possible answer. Now I go to 45. I'm going to plug it in to my inequality. Instead of a C, I'm going to have 45 plus 28 is greater than 72. Once again, I just simply bring down my greater than 72 and I do the math on the other side. When I add 45 and 28 together, I get 73. Is 73 greater than 72? Yes. So 45 is an answer. And then I do 46. I'm showing my work. 46 plus 28. Well, I bring down my greater than my 72, and then I add 46 and 28, and I get 74, and that answer is yes as well. 74 is indeed greater than 72. So what are my answers? 45 and 46. And then I circle my answers. All right, so we have this. So going through the process, then we can see where we have some of our inequalities that are just the greater than or less than sign. So when I plot them, I just circle where the number is and I fill in with the arrow. Less than would go to the left, greater than would go to the right. Some of them have the underline, they have the equal sign with them. So I'm going to plot them. I'm going to put the circle and I'm going to fill it in. I do that so that I know it could include the number that's given. And then once again, if it's less than, I shade to the left. If it's greater than, I shade to the right. We are finding inequality that the variable could be equal to. Now, I'm going to put this link on Canvas for you with the Math Antics guy. He has a good video also on basic inequalities. And since today is just about taking notes, I would like you to watch him explain how these inequalities work. Then, in our next class, it will just be working on our assignment.